Hello, I'm Ana Clara. I'm going to present this webinar on the topic the true cost of water at industrial facilities. So, a little about me. I've been a water research engineering in the Sustainable Manufacturing Group since March of 2019 in IMR. My degree is in sanitary engineering, and my background it has been into water and wastewater treatment projects at different types of manufacturing. So a little diagram related to water manufacturing, how is it? We can generally describe the system as a water demand in entrance and as output wastewater discharge. In general, we need a pre-treatment or a post-treatment in those systems. Also, sometimes we have reuse possibilities. So this is the general diagram for water manufacturing. Some facts and figures. We know that nowadays 11% of Europe population is being affected by water scarcity. And concerning about that, the Sustainable Development Goals made by United Nations in 2015 is regarding to water. And not only water, it's also related to industry, innovation, and infrastructure. So SDGs, they have this idea of implementing some action to end poverty, to protect the planet, and to ensure that all people enjoy peace and prosperity by 2030. And well, it's good to see that the SDG number 6, which is clean water and sanitation, is possible to be reached in manufacturing as water savings in terms of SDG 9, which is industry, innovation, and infrastructure. We know that industry represents 19% of global water demand nowadays, in which biorefineries and food industries compose the group for highly water consuming. And it's because it's not only use water as general stuff, it also use water as a reactant in this final product. Some perspectives for next year is that by 2050, this number of 19% of industrial use will be more 400%. So yeah, some increase for future. So in the sense, what are IMR services for water? We do water mapping. We also do metering, monitoring, design. Our portfolio also includes the cost of water demystification and water saving projects. The project I'm going to present today, its name is the true cost of water at industrial facilities. It has been a partnership between IMR, CI, and Wyeth Nutrition. Wyeth Nutrition is a dairy milk powder manufacturing facility located in Askeaton, County Limerick in Ireland. Dairy processing industry is one of the largest in the country, so it's an important one to be worried about. So the project itself, the main goal of this project is water management improvement. The system there is composed by a river in which the water is took upstream, it's treated, it goes to the users in which some parameters are monitored as flow, quality, and cost. Afterwards, it receives a post-treatment and goes downstream the river, the same river, by the way. The main activities of this project, it would be producing a water balance map for the site, also developing a methodology for metering, establishing tracking of cost, and at last, but not the least important, it would be designing business cases for water saving opportunities. So this company itself, it has a current infrastructure and all the companies they have. So how can we make it smarter? My answer would be digitalization, so IoT. And it comes in terms of IWN, so intelligent water networks, which would be intelligent device to guide strategy in terms of metering water and sensoring pressures and type of other data. It works perfectly together with SWN, which are smart water metering. This integration provides a very intelligent device with businesses related to cost and also customers' information, for example. It would be billing system or customer portals web. So going to the water map, first stuff to be done is understanding the water system. So to do that, we need to review drawings, specifications, documents. We have to capture test knowledge and do some initial discussions with colleagues who have this type of expertise in the water process in the factory. A site audit would come after this understanding, so we need to establish a state-of-art assessment in the facility. We have to produce the mass balance and also check a baseline for water consumption inside it. And at some points, the company can be interested in have some standards. So nowadays, we have been talking a lot about AWS and EWS. They are some standards related to water stewardship in Europe and also internationally. This specific project, they are worried about these two type of standards. We have also the ISO standards related to water that could be an extension of ISO 14000. So metering design, how can we do it? So the workflow, it would be basically at first building a water map, then defining the actual metering system inside the company, and then afterwards checking the objectives and desires output for the new system. To do it, we are worried about accuracy, so it's good to isolate system. We also are worried about smart systems, so it's not only just putting plenty of meters in the network, but we have to check which ones could be virtual meters to do some calculations and have the information needed. Leakage detection is also important, so we have to fragment the big pipes in this methodology. And I also consider very important an eye on water discharge, because then the facilities can be open to reuse possibilities. The true cost of water, so I like this conception of an iceberg in which we see the top and we don't see below, which are the real expenses of the company. So we have operating expense and also capital expense. In terms of operating expenses, I can tell about chemicals that we use for water treatment. I can tell also about non-revenue water, which is mainly leakage. Energy would be inside it. If you consider that to generate energy we need water, and on the other hand we need energy to pump water for the fuel system. We have to check the demand as it changes through the year, seasonally. It depends a lot on the type of company, of course, but there is also some demand expectations. In terms of capital expense, for you to provide the treatment, you have to pay for the system, so in general it's expensive. And storage the water is also part of tanks that we need to buy to include in the factory. Growth is also related to capital expense, as when you are going to buy your treatment system or plan your storage, you have to think that in a couple of years maybe your company will be larger than now. So this would be the conception for the true cost of water in a facility. So business case for water saving opportunities. What can you do in the facility to make the process better in terms of water, and then costs, of course. So I brought here an example related to water reuse at cooling towers. In this sense, we are comparing technology, implementation cost, water saving, and return investment in between scenario 1 and scenario 2. Scenario 1, it would be a case for membrane technology application. So we have implementation cost, which is considering expensive, but on the other hand, our water saving would be kind of good, and our return investment also higher in comparison to the implementation cost. Scenario 2, it would be a mixed bed filter example. It's less expensive than membrane technology, but our water saving is also less, and return investment the same, less. So the thing is that we go to our customer, we build these scenarios, and then we check what's better in terms of their water management required. So that's all, folks. I hope you enjoyed the presentation. I can be contacted by email, which is in the screen. And yeah, with this sentence, I will finish my presentation, which is all the water that will ever be is right now. Thank you.